Question 11, Part A. Seamus is making an access ramp for a building. The ramp is in the shape of a right-angled triangle. So here we have a right-angled triangle. We know that it's right-angled because we have this little square in the corner here, which represents a right angle. A diagram of the ramp is shown below. The lengths of the two sides are shown. The angle A is marked. So we have a height of 20 centimeters, and we have a base of 260 centimeters, and angle A. Part 1. Write down the length of the side adjacent to the angle A. So write in the adjacent side's length here. And part 2, write down the value of tan A as a fraction. Okay, so here we have a right angle triangle. And we need to label all the different bits that we have. So I'm going to start off with the hypotenuse, which is always the longest side. So I'm labeling that as H. The hypotenuse is always looking across at the right angle. So the hypotenuse is the longest side, and we label that as H. The opposite is always opposite the actual angle. So this is angle A, and the side that's opposite it is 20 centimeters. So I'm labeling this as O, this is the opposite. And then the other side that's left over is going to be the adjacent. So 260 centimeters is going to be labelled as A, the adjacent. So part 1, write down the length of the side adjacent to the angle A. That's going to be 260 centimeters. Part 2, write down the value of tan of A as a fraction. So we need to write out our formula SO, Ca, TOA. And SOH stands for sine equals O over H. So opposite over hypotenuse. Ca stands for cos equals A over H. So cos equals adjacent over hypotenuse. And TOA stands for tan equals O over A. So tan equals opposite over adjacent. So what we have to do is take TOA, because we were specifically asked for tan of A. So TOA is equal to tan, which equals O over A. So OA, O over A, opposite over adjacent. And then we're just going to substitute into this formula. So tan becomes tan of A, because we've angle A. The O becomes 20, because we labelled the 20 as O, the opposite side. The A becomes 260, because we labelled 260 as A. And 20 divided by 260 give us 1 over 13. So 20 divided by 20 goes once, 260 divided by 20 goes 13 times. So tan of A is equal to 1 over 13. Part 3. Use your answer to Part A, Part 2 to find the size of the angle A. Give your answer correct to the nearest degree. The angle A must be less than 5 degrees for the ramp to be acceptable. Part 4. Is Seamus's ramp acceptable? Tick one box only. So we're going to tick yes or no. Give a reason for your answer. So we're going to give a reason for our answer for whichever box we ticked yes or no. Okay, so in A part 2, we got tan of A is equal to 1 over 13. Now, when we don't know what the angle is, so we don't know what A is, we don't know what the angle is, we have to use the inverse function. So that means we press shift and then we press tan, and this will come up in our calculator, tan to the power of minus 1. So this is known as the inverse of tan. So we press the shift button and then we press tan, and tan to the power of minus 1 comes up, and a bracket will open. We press the fraction button, and we put 1 over 13, and then we press the close bracket button. It's important that we close the bracket. Then we press equals, and we get 4.3987 dot dot dot. So we were asked for answer to the nearest degree. That's basically the nearest whole number. So we look at the first number after the decimal point, and it's 3. So the 4 rounds down to 4, so it just stays as it is, basically 4 degrees. So this was 3, and the rule is 5 or more let it soar. So if this had been 5, 6, 7, 8 or 9, then this would have rounded up to 5. But if it's 0, 1, 2, 3 or 4, it just stays as 4. So 5 or more let it soar, 4 or less let it rest. So this was technically 4 or less, so it rests at 4. So we get approximately 4 degrees. So the rule is, when we do not know the angle, so we did not know what angle A was, we use the inverse, which is the shift function. So we press shift and tan, and we get the inverse of tan, tan to the power of -1. So the angle A must be less than 5 degrees for the ramp to be acceptable. Is Seamus's ramp acceptable? Tick one box only. So I've ticked yes. Seamus's ramp is acceptable. Give a reason for your answer. The reason is 4 degrees is less than 5 degrees. So we got 4 degrees as our answer, and that's less than 5 degrees, so yes, the ramp is acceptable. If we had gotten, let's say, 6 degrees, or 7 degrees, or 8 degrees, etc., if we'd gotten a number that was higher than 5 degrees, or greater than 5 degrees, then we would have had to take no. Part B. Killian is making a ramp for a different building. His ramp is also in the shape of a right-angled triangle. A diagram of his ramp is shown below. So we have a base of 224 centimeters. We have a height of x centimeters, and we have a hypotenuse, which is the longest side, of 226 centimeters. Use the theorem of Pythagoras to find the value of x. So Pythagoras' theorem, or the theorem of Pythagoras, is a formula in our formula book, and it is c squared equals a squared plus b squared. And Pythagoras' theorem is a formula that we use if we're trying to find an unknown length in a right-angled triangle. So here we have a right-angled triangle. We know it's right-angled from this little symbol here, this little square. And we've been given 2 of the lengths and asked to find a third length. So whenever we are dealing with just the lengths of a right-angled triangle, we use Pythagoras' theorem. So what we have to do is we start off by labelling our triangle. And we always label the longest side as C. And the other 2 sides get labelled as A and B. It doesn't matter which way we label the other 2 sides. This can be A and this can be B, or this can be A and this can be B, so long as the longest side is always the C. So I'm going to label 224 as A and X as B. So C squared becomes 226 squared. So 226 is my C, so 226 squared. A squared is going to be 224 squared. And B squared is going to be X squared. So then we have 226 squared equals 224 squared plus X squared. 226 squared gives me 51,076. 224 squared gives me 50,176, and x squared stays as it is. I want to get the x on its own, so I need to get rid of the 50,176. So I'm going to minus 50,176 from both sides, so they cancel out. And 51,076 minus 50,176 gives me 900. So I have 900 equals x squared. So the squared part comes over the equal sign and becomes square root. So I get x is equal to the square root of 900. So x is going to be equal to 30 centimeters, because the square root of 900 is 30. So the height here is 30 centimeters.